Okay, this video is to go over the worksheet that was simplifying trigonometric functions that you turned in for a completion grade. Just wanted to go through and do all the problems. You only had to do 10 even or 10 odd problems. Let's do all of them. So we're gonna start with number 1. It says that secant theta times cosine theta. So using reciprocal identities, secant is 1 over cosine, and then times my cosine, which is the same thing as cosine over 1. So when you do that, the cosines cancel out, and you're just left with 1. So the answer to number 1 was just 1. Let's try another one. So number 2. Cotangent theta times sine theta. So cotangent is the same thing as cosine theta over sine theta times sine theta, or sine theta over 1. The sines cancel out, so this one is just cosine theta. Number 3, Number 3 says 1 plus tangent squared theta. This is just a Pythagorean identity. This on your formula sheet says it's equal to secant squared theta. Number 4 says sine squared theta plus cosine squared theta. Again, this is a Pythagorean identity. I call it a Pythag identity. Sine squared plus cosine squared from your formula sheet is just 1. Number 5. Number 5 says I have tangent theta times secant theta. I think this is the weirdish one. It's okay. This is sine theta over cosine theta times 1 over cosine theta. Nothing cancels out this time, so when you multiply fractions, you multiply straight across. So I get sine theta over cosine squared theta, which is pretty much all you can do. If you wanted to, you could look at your Pythags and do cosine squared theta plus sine squared theta equals 1. So that cosine squared theta equals 1 minus sine squared. And you could plug that in right here if you wanted instead. But that's not going to help me clean anything up really. So you can leave it like that. Number 6 says I have tangent squared theta times cosecant squared theta. Tangent sine over cosine, so tangent squared is sine squared over cosine squared times 1 over sine squared. The sine squareds cancel out, so I have 1 over cosine squared. 1 over cosine squared is the same thing as secant squared. So your answer to this problem is secant squared. Number 7, if you don't love fractions yet, you need to learn to love some fractions. So sine theta times tan theta times cotangent theta times cosecant theta. So this is sine theta over 1 times sine theta over cosine theta times cosine theta over sine theta times 1 over sine theta. So this sine on top can cancel out with this sine on bottom. This sine on top can cancel out with this sine on bottom. This cosine on bottom can cancel out this cosine on top. So my answer is simply just 1. Number 8. Number 8 says that I have sine squared x plus cosine squared x all over cosine squared x. Sine squared plus cosine squared is 1 over the cosine squared that I had. 1 over cosine is secant, so 1 over cosine squared is secant squared x. Number 9. Secant theta minus sine theta tan theta. So 1 over cosine theta minus sine theta over 1 times sine theta over cosine theta. So I get 1 over cosine theta minus sine squared theta over cosine theta. Because they are the same, I can simplify and reduce what I have into one fraction and combine like terms. So 1 over sine squared theta over cosine theta. So I can use the Pythagorean identity, and I can say that this thing right here is the same thing as cosine squared theta, because sine squared theta plus cosine squared theta equals 1. And so I can move that sine squared over so that cosine, so that means cosine squared equals 1 minus sine squared. So I can do a cosine squared theta over a cosine theta. That's the same thing as saying cosine theta over cosine theta. They cancel out, so the answer for this one is simply just a cosine theta. Okay, number 10. Secant squared x minus 1 over secant squared x. Lots of ways to do this problem. I think I'm going to do the top is a Pythag, so secant squared x minus 1 is the same thing as tangent squared x. And then over my secant squared x. And then I can go up to sines and cosines, so I get sine squared x over cosine squared x over 1 over cosine squared x. Dividing by fractions is easy as pi. Flip the bottom and multiply. So you get sine squared x over cosine squared x times cosine squared x over 1. The cosines cancel off, so you are left with just a sine squared x. Ooh, number 11. Okay, let's try this. There's a lot of stuff going on. So I got cosecant x over sine x minus cotangent x over tangent x. Okay, here we go, piece by piece. We got this. So cosecant is 1 over sine x over sine x over 1 minus cosine x over sine x over sine x over cosine x. So for both of these things I'm circling in blue, I'm going to do this thing 2 times. Dividing by fractions is easy as pi. Flip the bottom and multiply. So I have 1 over sine x times 1 over sine x minus cosine x sine x times cosine squared x over, oh, not cosine squared, so sorry, just cosine over sine x. Multiply straight across in your fractions. 1 over sine squared x minus cosine squared x over sine squared x. So this is the common denominator, so we're going to do 1 minus cosine squared x over sine squared x. This top piece right here is a Pythagorean identity. 1 minus cosine squared is a sine squared. So I get sine squared x over, over sine squared x. That's just 1. Number 12. So let's see. I got secant squared x minus tan squared x plus cotangent squared x. So this piece right here is a Pythagorean identity, because I have tan squared theta plus 1 equals secant squared theta. So I can move the tangent over, and so secant squared theta minus tan squared theta equals 1. So this whole blue piece is just 1. And then I have plus cotangent squared x. And this itself is another Pythagorean identity, which is just cosecant squared x. So there's my answer. (13) Cosine x times secant x minus cosine x over secant x. So this is going to be a cosine x times a 1 over cosine x minus cosine x over 1 over cosine x. Well, this first piece, those cosines cancel off, so we get a 1 minus cosine x times flip and multiply cosine x over 1. This is a 1 minus cosine squared x. That's a Pythagorean identity. 1 minus cosine squared is a sine squared x. (14) Secant squared x over secant squared x minus 1. Secant squared x minus 1 is just tangent squared, so I get secant squared x over tan squared x. Secant squared is 1 over cosine squared x over sine is sine squared x over cosine squared x. So I can flip and multiply. So that's going to get me 1 over cosine squared x times cosine squared x over sine squared x. Cosines cancel off, so you get 1 over sine squared. 1 over sine squared is called cosecant squared x. (15) is a beautiful thing, and I am pretty sure you and 15 were not friends because it involves a math thing called factoring, which you love so much. So if I had asked you to factor x squared minus 9, you would probably tell me x plus 3 and x minus 3. Let me rewrite what I have. This is sine squared theta squared minus cosine squared theta squared. This is still my a squared minus my b squared, which you learned in algebra was a plus b and a minus b. So this factors. This factors into sine squared theta plus cosine squared theta times sine squared theta minus cosine squared theta. This piece right here is equal to 1 by Pythagorean identities. And this piece, the second piece in white, you could leave alone. So you would just have told me sine squared theta minus cosine squared theta. Just a little prelude to what we're doing in a week or so. If you look under a thing called double angle formulas, this thing is from the double angles. And this thing is equal to cosine 2 theta. So the best and final answer is cosine 2 theta. However, at this point in your pre-cal trigonometry life, I expect that you would have told me sine squared theta minus cosine squared theta, and that would have been, in this situation, perfectly acceptable. 16. 16 says tan theta times cotangent theta minus cosine squared theta. So tangent is sine theta over cosine theta times cosine theta over sine theta minus cosine squared theta. You'll notice that in this problem I've opted to go to sines and cosines, which means my last cosine squared, I didn't change it to secant or anything. If you're going to go to cosines and sines, then go to cosines and sines. Make all of them the same. This sign and that sign cancel out. This cosine and that cosine cancel out. So this first fraction just becomes a 1. Oops, I wanted that to be in white. I'm sorry, let me try that one more time. So this first thing becomes a 1 minus a cosine squared theta. I gave up on the white. It's just going to be in blue for now. It's okay. 1 minus cosine squared is a sine squared from Pythagorean identities. 17 sine x plus tan x over 1 plus secant x. Okay, this is going to be a lot of fractions. Sine x, I'm going to do just the numerator first, okay? Sine x plus sine x over cosine x. I'm going to add to this fraction, or multiply by cosine x over cosine x so that I can find common denominators. So this is going to become a cosine x sine x over cosine x plus a sine x over cosine x. So I can make this one fraction. So when I do that, I get cosine x sine x plus sine x all over cosine x. Okay, now I'm going to grab another color and go back a little bit. I'm hoping something magical happens. I've done this problem before. I'm going to do the bottom for a second. 1 plus 1 over cosine x. I'm going to change my 1 and do a cosine x over cosine x because that's still 1 plus my 1 over cosine x. I'm going to combine these fractions. Cosine x plus 1 over cosine. This would have been my denominator right here. So when you divide by something, by a fraction, you flip and multiply. So I'm going to flip it and multiply by cosine x over cosine x plus 1. So I can cancel off these cosines. And I can, in the numerator, I'm going to factor out a sine x. So when I do that, I'm left with cosine x plus 1 times a 1 over cosine x plus 1. So the cosine x plus 1 and the cosine x plus 1 are gone, and you are left with simply just a sine x. Okay, number 18 says I have cotangent x plus tangent x over cosecant squared x. In the top, I'm going to do sines and cosines. So I'm going to do cosine x over sine x plus sine x over cosine x. And I'm just going to do the numerator for a second. I'm well aware this denominator still exists, but I'm going to hang on for a quick second. I'm going to multiply by sine x over sine x. And this one by cosine x over cosine x. So when I do that, I get cosine squared x over sine x cosine x plus sine squared x over sine x cosine x. And because these denominators are the same, they equal, or because the denominators are the same, I can add the numerators. So cosine squared plus sine squared is 1. They equal 1. So cosine squared plus sine squared is 1. It's a Pythagorean identity. So 1 over sine x cosine x. So I'm going to go back and add my original denominator back in. So I have 1 over sine x cosine x over, it was cosecant squared, which is 1 over sine squared x. So I can flip and multiply. So 1 over sine x cosine x times sine squared x over 1. I'm going to write this one more time. 1 over sine x cosine x times sine x sine x, because sine squared means sine times sine over 1. These signs can cancel out. Oh, why are things just moving? I'm trying to make them smaller. No, we're just going to keep moving things up then. And then because the signs cancel out, I have left a sine on top and a cosine on bottom, which is going to me a tan x. So there's my final answer for number 18. Number 19 says I have 1 plus cosine theta times cosecant theta minus tangent theta. So, I don't know, let's try foiling. So 1 times cosecant is cosecant theta. 1 times negative tangent's negative tangent theta. Cosine times cosecant is going to be plus cosine theta, cosecant theta. Oh, sorry, that should be a minus sign. And then minus cosine theta, cotangent theta. So now I'm going to make everything sines and cosines. So 1 over sine theta minus cosine theta over sine theta plus cosine theta over sine theta minus, this is going to be a cosine squared theta over a sine theta, and that's because this is a cosine, and then my cotangent is a cosine over sine, like that. So cosine times cosine made my cosine squared. So then, all the denominators are the same, so I can add the numerators, which means this negative cosine and this positive cosine are going to cancel each other out. So now I'm left with 1 minus a cosine squared theta over sine theta. Using our Pythagorean identities, 1 minus cosine squared is the same thing as sine squared theta over a sine theta. Sine squared is the same thing as sine theta times a sine theta. And then on the bottom, I had my sine theta. So my sines cancel out, and I'm left with 1 sine theta on top, which is my final answer. Okay, kiddos, last problem. We got this. Number 20. 4 cosine theta minus 3 sine theta squared plus 3 cosine theta plus 4 sine theta squared. So I'm literally going to follow these things out. I'm going to do 4 cosine theta minus 3. Oh, it's horrible. Let me erase that. Sorry. Minus 3 sine theta. 4 cosine theta minus 3 sine theta. And I'll multiply that out. And so let's FOIL this out. So you're going to get 6. Oops. I don't know why the white happened. Or the blue. I wanted white. So 16 cosine squared theta minus 12 cosine theta sine theta minus 12 cosine theta sine theta plus 9 sine squared theta, which is the same thing as 16 cosine squared theta minus 24 cosine theta sine theta plus 9 sine squared theta. Now I'm going to go to this piece right here. I have to do the same idea. I have to multiply it out, FOIL it out. 3 cosine theta plus 4 sine theta times 3 cosine theta plus 4 sine theta. So you get 9 cosine squared theta plus 12 cosine theta sine theta plus another 12 cosine theta sine theta plus 16 sine squared theta. So what I'm going to do now is I'm going to add my white and my red together. So I'm going to, let me write one more step. I can add these two middle pieces together. So I get 9 cosine squared theta plus 24 cosine theta sine theta plus 16 sine squared theta. So these two pieces were that's what I was saying, they were added together. So to this red piece, I still have this piece up here. So I need to add a 16 cosine squared theta minus a 24 sine theta cosine theta, or cosine theta sine theta, either way, plus 9 sine squared theta. So this positive 24 cosine sine, this negative 24 sine cosine or cosine sine, they're the same thing. They get to go away. So now I'm left with 9 cosine squared theta plus 9 sine squared theta plus 16 sine squared theta plus 16 cosine squared theta. And so these two right here have a 9 in common. So it's cosine squared theta plus sine squared theta. This is just 1, so I have 9 times 1, which is just 9. Similarly, these have a 16 in common. I'm left with sine squared theta plus cosine squared theta, which again is just 1. So I have plus 16 times 1, which is just 16. And 9 plus 16 is 25. Oh, that was so much fun.